Hello everyone. Good evening. I'm audible to all of you. Okay, I think I'm audible, guys, to all of you. Hi, Bappy. How are you doing? Yes, I'm doing well. Amarnath, what about you? So let's wait for 1 minute, guys. Let everyone join, then we can start the session. Yeah, thanks for the confirmation. Okay, so guys, welcome back with another session today. Today is the day 2 of our MLOps production ready deep learning project implementation. Yeah, hi Adil, hi. Yes. So I think you remember yesterday I conducted one session and that was our day 1. So there we saw the project introduction and the setup. Okay. So if I just do the little bit of revision like what we did yesterday, I think you remember first of all we saw the project introduction and which project actually we're doing, guys. We're doing chest disease classification from CT scan image. And what kinds of chest disease actually we'll be trying to classify, because I think I already showed you the data. So let me show you the data again. So here is the data. Let me just open it up. Project CV data. Yes, so CT scan image. Okay, so you can see we are having adenocarcinoma affected chest and normal chest. Okay, so this is the normal chest and this is the adenocarcinoma affected chest. Now if you ask me what is adenocarcinoma exactly, so those who are from medical background, they already know. Okay, so let me search on Google actually what is adenocarcinoma. It's a kind of cancer actually. It happens on the chest. So see guys, this is the adenocarcinoma cancer. Okay, how can I reach to you? Simply you can connect me on my LinkedIn. Okay, so here you can reach to me. So this is my LinkedIn profile. It is available in my YouTube description. You can check it out. So this is the adenocarcinoma cancer, guys. Okay, so that's how this cancer looks like. So what they did actually, they collected CT scan image. Okay, CT scan image of the chest, and if you see that adenocarcinoma cancer, so there are some extra muscles. So see, there are some extra muscles here. So this is called actually adenocarcinoma cancer. Okay, so we have to just try to classify this cancer. Okay, so let's see if user is uploading any kinds of image. So my system will be able to classify whether it's a adenocarcinoma affected chest or whether it's a normal chest. Okay, so this kinds of project will be implementing here. And again, this is a image classification problem statement, because I think you know inside deep learning, guys, what we have. Tell me, inside deep learning what we have. Any idea? Inside deep learning what we have? Sorry. So we have artificial neural network, ANN. We have convolutional neural network, CNN. Okay, then inside CNN what we have, guys? We have object classification, then we have object detection. Okay, then we have something called object segmentation. Then we have object tracking. Okay, then we have GANs. Okay, so here we'll be doing this problem statement, object classification problem statement, because we have to classify whether a image is a adenocarcinoma or it's a normal image. So you have to build a classification model here. Why do you use the same project template for each project? See, because I personally like this template, because I told you, na, so template is not actually fixed thing. It's not like that you have to follow this particular template only. You can create any kinds of template. For me as a developer, I prefer this template. Okay, let's say whenever I implement any kinds of end-to-end projects, for the deep learning, I prefer this template. For machine learning, I prefer that template. I think that template I showed you in my first project implementation. Okay, so that's how, if you have any good idea, if you have any your own idea like how to create a template, and this template actually you can use in your implementation, you can feel free to use it. You don't need to use my template. Okay, template is just a way of organizing your code, nothing else. It's just a way how you are organizing your code, that's it. Without template also I can implement the project, but what will happen, code management would be difficult for me. Yes or no? Fine. Then we are having another concept called RNN, recurrent neural network. Inside that actually we are having all kinds of NLP related tasks, right? So I think you know ANN we don't use, because ANN is just for the understanding, okay, understanding of the neural network, how neural network works exactly. So this will give you the foundation, like fundamental understanding of the deep learning. Then you have to start with the CNN, that means convolutional neural network, and here your actual project implementation will start. Okay, so that's why we are not going to use ANN here. So ANN is only for the understanding purpose, that's it. I hope it is clear now, right? Then going forward, we'll be also learning about NLP project implementation, GenAI project implementation. Okay, everything we'll try to cover here. Fine. So I think yesterday, remember, we covered the GitHub repo setup, then project template creation, project setup, login exception and utility, project workflow. Now today, I think I remember, you remember today I was about to discuss the MLOps tool, like MLflow and DVC, because going forward, I'm going to use these two tools actually in my project implementation. One is MLflow, another is DVC. Okay. Now, in this video, I'll tell you how this MLflow works and why we need the MLflow, how DVC works. Okay, why we need the DVC, each and everything I'll try to discuss. Then from the next class itself, we will start with our implementation. Okay, this is the idea. So today we are about to discuss MLflow and DVC, guys, all of you. Okay. So we'll be learning how we can do the setup, how we can track, let's say, all the experiment in the cloud server. Okay, for this, what kinds of server we can use. So everything I'll show you as a setup, because currently in the MLflow, so many things have been updated. So if you see my previous video, I think you remember in my YouTube channel, I also created tutorial related MLflow. Let me show you. So if I go to my playlist section, so here, I think you remember, we created tutorial related MLflow, see MLflow for data science, MLOps. Okay, so if you see this video now, this is a very, I think, let me see, 1 year back. Okay, 1 year back actually I recorded this video. Now in this 1 year actually so many things has been updated in MLflow. Okay, so that is what actually I'll try to cover. So what is the update and how you can connect with the server. Okay, everything I'll try to teach you here. So for interviews, should I focus on the project like ML, DL, NLP or data structure and algorithm? For interview, first of all, try to prepare some end-to-end projects, okay, from the ML, DL, NLP, GenAI. And if you are going for any product-based company, that time you also need data structure and algorithm concept to write efficient, optimized code. Okay, that is the idea. That's it. All right, guys. So now let's start our MLflow discussion. Okay, MLflow discussion. Now, before starting with the MLflow, see, I'll be discussing about the hyperparameter tuning and the experiment tracking. Okay. Now, I think you remember, guys, in our first project, whenever I did the machine learning project, there I was performing the hyperparameter tuning. Yes or no? Do you remember, guys? Hyperparameter tuning. Hyperparameter tuning. Remember? So inside hyperparameter tuning, guys, what we used to perform? So let's say we are having some list of the parameter, let's say P1. So inside that I'm having some parameter, let's say this is the learning, let's say 0.001, 0.002, okay, 0.003. So different kinds of learning rate. Okay. Now let's say there is another parameter P2. inside that, let's say we are having different kinds of optimizer. Let's say stochastic gradient descent, SGD. Then we are having something called ADAM. Okay, then we are having something called, let's say RMS prop, RMS prop. Now in hyperparameter tuning, what do we do, guys? So let's say this is my model. This is my model. So we'll be picking up different parameter. We'll be picking up different parameter, and we'll try to train this model, and we'll try to see the accuracy score. Okay, accuracy score, whether this accuracy is increasing or not. Okay, then let's say this parameter is done. Again, what he will do, again he will take this parameter, again he will give to the model, and again you will see another accuracy. Okay, again he will take this parameter, again we will see another accuracy, yes or no. And then it will compare all the model. Let's say this model is giving, let's say this parameter, the first parameter. Let's say this is the first parameter. How I can write, let's say this is the first parameter. Here I can write first accuracy, second accuracy, third accuracy. Okay, now this is what your first parameter. So first parameter is giving, let's say 0.88, 88% accuracy. Second parameter is giving, let's say 0.89, and third parameter is giving, let's say 0.91. Now tell me which actually, let's say, parameter is working better here. Obviously the third parameter, that means the last parameter, these two parameter, yes or no. Then what we'll do, we'll say select this parameter and we'll try to finalize my model, yes or no. So that's how you can take different kinds of parameter. You can do the hyperparameter tuning of a model. And this model, let's say this is the machine learning model, and machine learning model is nothing but it's a statistical model, yes or no. Statistical model, statistics. Okay, statistical model. That's why using hyperparameter tuning is very easy, because here I don't need GPU I don't need to train this model, yes or no. I can do it on my CPU machine. Yes, tell me guys, do I need a GPU inside machine learning? Anyone? Did you use GPU in your machine learning? Tell me. Because if you see the calculation of this machine learning algorithm, it's not that much of complex. It's like very small equation. Let's say if I'm considering linear regression. So what is the equation of linear regression? Y is equal to mx plus c. This is the equation only, right? And if you see the equation, how many weights we are having? We are having only two weights, m and c. So these two weights I have to update, and this is my input data, and this is going to be my output, yes or no. But whenever I'm talking about deep learning, so how deep learning architecture looks like, guys? So we're having different nodes, input nodes, hidden nodes, okay, then output nodes. Then these nodes should be interconnected with each other, like the neurons, yes or no. And what you will have, you will have different weights. That's a weight 1, weight 2, weight 3, weight 4, and so on. Even we will also have the bias, let's say B1, B2, B3, okay, B4, and this is going to be your y hat, and here is the input x1, x2, and x3. Now tell me how many weights you are having in this architecture, guys. Any idea? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 weights you are having. So 12 weights, let's say parameter you have to update during back propagation. Okay. Now how many hidden layer we are having? We are having 2 hidden layer only. Now just try to consider about, let's say, 100 layer architecture. 100 layer architecture. Now how many of, let's say, parameter you will have in that model? Try to think about. And definitely if I want to train this kinds of model, I need GPU, yes or no. Okay, you need GPU based machine, because it's a complex architecture, so many calculation is happening, right? So I need GPU based machine here. Now tell me, can I perform the hyperparameter tuning here? If you have trained any kinds of deep learning model, guys, in your career, then you can give me the answer. Like doing the hyperparameter tuning would be easy for me, or it would be hard? Tell me. Did you ever train this architecture, guys? ResNet 50. ResNet 50. At least 500 epoch. Did you ever train? Anyone? ResNet 50, 500 epoch. Did you train? That's on Google Colab. I'm talking about Google Colab. Google Colab, the free one. So what is the time? What is the training time? If your data size is huge, so training time would be also huge, right? Sometimes it takes 1 hour, 2 hours, okay, to execute the entire model training. Now just try to tell me. Tell me now if I'm performing these kinds of hyperparameter tuning. That means if you're taking these kinds of parameter, let's say these two parameter again, this two parameter again, this two parameter. Now just try to see the time, try to see the computation. So it will take lots of time. It's not easy. Okay, doing these kinds of hyperparameter tuning in the deep learning model, it's not easy. Okay. Again, I will give you another scenario. Let's say you don't want to perform the hyperparameter tuning. Let's say you have some certain parameter. So have you heard of this model, guys? Anyone? So those who are already work in the machine learning, they already know ElasticNet, sklearn. Have you heard of this model, guys? Anyone? ElasticNet. We can also call it regularization model, right? ElasticNet. Have you heard of this name? Anyone? I think you already used ElasticNet. So linear regression, I think you know, right? So whenever, let's say, my model will get overfit, underfit, that time we can use this ElasticNet because it's some regularization technique as well, right? So ElasticNet, let's consider about ElasticNet model. And inside ElasticNet, you will see some of the parameter. How many parameter, guys? You can see inside ElasticNet, guys. You can see here, alpha is there, L1 ratio is there. Okay, fit, then intercept is there, then pre-compute is there, max iteration is there. So different kinds of parameter you can see inside ElasticNet. But as of now, let's try to consider alpha value and L1 ratio. Okay, so here, let's say I am doing one project. Okay, I am doing one project, and as a data scientist, I have selected certain parameter. Okay, let's say here we are doing one machine learning project. ML project you are doing. ML project you are doing. Now what you did, actually, you selected one model called ElasticNet. Now here I'm considering two parameter. One is like L1 ratio, and there is like alpha parameter. Okay, alpha parameter. Okay, now let's say here I will create a list. First of all, let's say L1 ratio, L1 underscore ratio. So this is going to be a list. Let's say I have selected certain value here. Let's say 0.5, 0.3, 0.4. Let's say these are the value I have selected as a data scientist, because let's say I have been working in this field. It's been, let's say, 5 years, 6 years. And I know actually different kinds of parameter, which parameter will work. Now see, if I ask you as a learning rate, as a LR, learning rate, so which parameter you usually decide? Learning rate, LR. I think you know, guys. So this thing, you don't need to do the hyperparameter tuning. You already know. If I'm taking this learning rate, then my model performance would be good. Can anybody tell me the learning rate value you usually select whenever, let's say, you define any kinds of deep learning architecture or machine learning architecture? What is the learning rate, guys, you usually take? I think you already know. We take 0.001. This is the learning rate. Yes or no? This is not very small. Even this is not very, big number. Okay, it's a kinds of medium number we have taken. Okay, that's how. Let's say you know about some parameter, L1 ratio, then alpha value. Let's say you have 3 to 4. Yeah, you can also take 0.01. That is also fine. You can also take 0.001. That is also fine. Okay. Now let's say as a data scientist, you selected some of the parameter. Let's say L1 ratio, you selected these are the parameters 0.5, 0.3, 0.4. In between, some of the, let's say in between, some of the parameter will give you good performance, but you are not sure which one will give you the good performance. Okay, now I have to find out somehow. Now let's define another parameter. Let's say alpha value. So alpha value, let's say you have taken 0.1, 0.9, and let's say 0.2. So let's say these three value we have taken. Now if I want to find the best model out of it, the best parameter out of it, what I have to do, guys? I have to do the experiment tracking. So what I will do, first of all, let's say this is my model. This is my model, elastic net model. So let's say first of all I will take these two parameter. That means L1 ratio I will take 0.5, alpha value I will take 0.1, and let's say this is my first experiment. This is my first experiment. Okay, now after taking these two parameter, let's say I'm getting the model accuracy 0.59. Okay, now let's go to the second experiment, second iteration. In the second iteration, again I'll take the model. Again I'll take two parameter. Now tell me the next parameter, 0.3, 0.9. So 0.3, 0.9, and let's say this is giving me 0.77. Okay, this is the accuracy score. Now I'll go to the third iteration. Okay, third iteration. Then I'll take the model again. Again I'll take the parameter. So 0.4, 0.2, 0.4, 0.2, and let's say this model is giving 0.91. Okay, this is the accuracy. Now let's say you are taking, let's say 100 parameter. Okay, 100 let's say value, or let's say 50 value. That time how many steps you have to perform, guys? 50 time you have to do the experiment. And to remember, these are the accuracy, these are the value. What you have to do, guys? You can manage the Excel sheet you can manage, yes or no. So inside Excel sheet you can create actually column, some of the column. So let's say the first column you can keep for the first iteration. Second column you can keep for the, let's say, L1 ratio. Third column you can keep for the alpha value, and last column you can keep for the accuracy score. Okay, that's how we can track all the accuracy. All the accuracy you can track, all the experiment you can track. Now tell me, is it an efficient way? This is a manual approach. At the end, this is a manual approach we are doing. Manually we are collecting our, let's say, information, and we are adding inside our Excel file. And now if I tell you, just try to figure out the best model out of it, then again you have to manually see, okay, so this is the parameter, this is the accuracy score, this is the parameter, this is the accuracy score, this is the parameter, this is the accuracy score. That's how we have to manually figure out the best model with best parameter. Okay, so completely manual effort you are doing. And what I told you about MLOps, guys, what is MLOps exactly? Tell me. Anyone remember what is MLOps exactly? MLOps is just a tool. This will help you to automate your work. Yes or no? This will help you to automate your work. That means whatever work you can do manually, that work actually can be done automated with the help of MLOps. Okay, this tool will help you to perform the automation, right? And that's why MLflow comes into picture. Okay, MLflow comes into picture. So what MLflow does, the experiment tracking you did manually, it can be done automatically inside MLflow. That means only you just need to use some MLflow related, let's say, syntax inside your code. It will automatically track all of the experiment you are doing, and it will give you one beautiful user interface. In that beautiful user interface, you can visualize the plot, you can visualize the graph, you can visualize the loss, accuracy, everything, and based on that you can select your best model out of it. That is the advantage to use MLflow. I hope it is clear now. What is MLflow exactly, guys? This is for experiment tracking. Now if I go to the MLflow website, let me show you. Nowadays MLflow integrated so many technology in their, let's say, functionality. So if I go to the MLflow, nowadays they have also integrated generative AI. So generative large language model evaluation you can also perform with the help of MLflow. See, ML and Gen AI made simple. I told you now previously, if you see my previous tutorial, it was only for the machine learning, but currently they have also updated with the deep learning pipeline as well. Okay, now build better model and generate generative AI apps on unified end-to-end open source MLOps platform. Okay, now you can see the things I told you, experiment tracking. So that's how actually it does the experiment tracking. You can see, so it will give you one beautiful user interface, and this is the experiment tracking it has done. See, different experiment. Based on that, it has given me different graph. Now by seeing this graph, actually you can select the best model out of it, and I'll tell you how to understand this graph. Okay, so this is called parallel coordinates graph. Okay, parallel coordinate graph. So with the help of this graph, actually you can identify your best model. Got it? Now you can see different kinds of contributor companies, they are using this MLflow, and this is production grade MLOps tool, guys. All let's say very big tech companies are already using this MLflow in their implementation. So it's not like it's just a POC kinds of tool. It's a production grade tool, guys. You can use it. Fine. See, with the help of MLflow, you can perform experiment tracking, visualization, generative AI, observability, evaluation, models, model registry, serving. So these are the things you can perform. So here we'll be using MLflow for the experiment tracking. Okay, experiment tracking purpose will be using MLflow. Even you can also perform the model registry. That means it will register your model. If you want to create some more, let's say, advanced architecture, advanced kinds of, let's say, MLOps architecture, that time you can also perform model registry, model serving. It is also possible. So maybe in future I will create some more end-to-end project. There I will tell you how we can use SageMaker platform. Okay, let's say if I am doing model registry, so directly I can serve that model in my SageMaker. Okay, SageMaker platform. This kinds of pipeline can be also created. Okay, with the help of MLflow. But as of now, first of all, try to see the experiment tracking, how experiment tracking can be done. Fine. So again, guys, you can visit this website and you can read like what are the services they are giving and all. Even they're having one beautiful documentation. So let me open the documentation. So if I click on the get started, so maybe it should open the documentation. See, guys, this is the documentation. Now they have given the example, different examples. So you can see a beautiful blog. So if you want to learn about MLflow, you can see the blog. All kinds of integration, all kinds of, let's say, example they have already given. If you want to looking for source code, now source code is already there. Let me tell you. So let's say if I'm doing experiment tracking, MLflow tracking quick guides. Now if I click here, see, this is the code. So these are the code implementation they have already given. Okay, so what I did, I simplified. These are the implementation, and I'll show you how this MLflow can be used. Okay, that is the thing. Now let me close. So guys, are you excited? Let me know. Are you excited, guys? Excited about the session? If yes, so please send me like, send me any kinds of emoji in the chat so that I can get a confirmation from your side. Everyone excited? Missing you in iNeuron. So now I'm here. I think you are not going to miss me. Yes, so that's why I'm conducting live session, guys. I could have recorded this project as well, and I can publish in my YouTube channel. But what will happen? I'm giving the recorded session there. Okay, so I won't be able to interact with you. That's why I'm conducting this kinds of live session. Because what do you feel like learning project implementation? Is it better in live session or is it better in recording session? Let me know, guys. What do you feel like? If you feel like, okay, it is better in recording session, I'll put the recording. And if you feel like, okay, it is better in live session, then I will continue the live. Because what I feel like, live learning is always, I mean, cool. Yes or no? So whatever time you are spending, let's say 1 hour, 1.5 hours, so you are spending some quality time. Okay, it's not like that we're doing the time pass operation. Definitely this session will help you a lot to upgrade your skill, to know about the end-to-end implementation, to know about the MLOps, which is required nowadays in the industry. Okay, great. So please hit the subscribe button. So let's hit 15k subscriber, guys, as soon as possible in my YouTube channel. If you haven't subscribed, let's hit the subscribe button, all of you. Live sessions are great, but takes a lot of time. In recorded session, you can watch in 2x. Yes, right. That is also fine, but But let's say in recording session, you are having one issue, or whether you are not able to understand this concept, you won't be able to interact with me. So again, after live, it will be in a recorded form in the YouTube. That time you can do the 2x operation. Okay, that is also fine. Okay, but if you ask me which one is better, I'll tell you a hybrid mode, like live as well, recording as well. Let's say if I'm teaching the project implementation and all, if I'm teaching any, let's say, advanced concept, that time I will prefer live session. And if I'm teaching any basics thing which takes less time, I can do the recording that time. Okay, both is required. Fine. Now let's start with our MLflow demo. Okay, so for this, what I will do, guys, I will open up my local folder. So all of you can open up your local folder. I think, remember, we created one. Just a minute. I think I created one folder from my project. MLOps production ready deep learning project. Yes, this one. No, I'm also working with other company. Soon you will get to know. I'm working with Euron. Okay, Euron. Soon you will see the announcement of the Euron, what we are coming up with Euron and all. Okay. Apart from that, in my free time, I am also, creating the content in my YouTube channel. Okay. Great. So now here, what I'm going to do, I'm going to open up my Visual Code Studio. So let me open up my Visual Code Studio. So this is my Visual Code Studio. Let me zoom. Okay, so now here what I'm going to do, guys, I'm going to create a folder here. I'm going to name it as MLOps underscore tool underscore demo. Okay, inside that I'm going to do the experiment. Okay. See, if you see my experience, actually, I had worked, I was working as a developer, okay, with so many companies. So there I learned about this end-to-end implementation and everything. Okay. Then I started actually mentorship. But I joined as a developer. Okay. I have worked around 2 to 3 years in the development field. Still, I'm doing the development. It's not like that I'm teaching only. Still, I'm doing the development. With that, I'm also doing the mentorship. That means I'm teaching you. Okay. Yes. All right. So now here, I'm going to open up my terminal. Now, make sure you have activated the environment. So previously, sorry, in our previous session, we created one environment, and you remember, called chest. Let me activate that one. So conda activate, okay, chest. This was the environment. Now let me clear. Okay, so I'm going to open up my VS Code here. I think I can open up inside this folder. Okay, that would be fine. Okay. Now here I'm going to create a file called requirement.txt. Requirements.txt. And inside that, I'm going to mention the requirements. Okay. I think, remember, I already installed MLflow there. So here is the MLflow. Okay. And I'm going to use this version 2.2.2. Okay. This is the stable version of the MLflow. Fine. Okay. Now let me install the MLflow. And how to install the MLflow, guys? I think, remember, we can do the pip install -r requirement.txt. So for me, requirement is already satisfied, but for because yesterday we already installed MLflow, I think, remember. Okay, so I don't need to install again. Okay. Fine. So here I'm going to show you one very easy demo. So I'm going to create a file, demo.py. Okay. So inside that I'm going to import some of the library. First of all, let me import. So these are the library I need. Let me select my environment. So I am using just environment. Okay. Now see. So here, what we'll be doing one small machine learning project called wine classification. I think you remember wine, red wine classification, guys. Wine quality classification. Did anyone do this project, guys? Wine classification, red wine. I think you know there is a data set inside Kaggle. Red wine data, Kaggle. Okay, so we'll be using this data set and we'll be doing one small, actually, we'll be creating one small machine learning model. Okay, see, this is the data, red wine data. Okay, so here is the CSV file. And this data is already available in a URL. Let me show you. So it is available inside a GitHub URL. So this is the URL, guys. So this is the data set. Okay, so it is having some column like fixed acidity, volatile acidities, citric acid. Okay, based on that I have to predict the quality of the wine. So this is the data. Fine. So now the first thing what I have to do, I have to import some of the library, and you can see here I have imported all the necessary library for like machine learning, let's say pandas, numpy. Okay, then I've also imported some of the, let's say, matrices like mean squared error, mean absolute error, R2 score. Now tell me, these are the metrics, is a classification matrix or it's a regression matrix? Let me know, guys. Mean squared error, mean absolute error, R2 score, it's a classification matrix or it's a regression matrix? Let me know. If you have done the machine learning, I think you know these are the. Any idea, guys? Classification or regression? Regression. That means this is a regression problem statement. That means I have to predict the quality of the wine, right? Then tent split, elastic net. I already told you we'll be using one model called elastic net. Okay, elastic net model, because it's a regression model. Got it? Then URL parser. I'll tell you why URL parser is required. Then here you can see I'm importing MLflow. Okay, MLflow, and from MLflow I'm importing some of the more functionality, like you can see infer signature, sklearn. Now if you go to the MLflow, now MLflow has different integration. Let me show you. So MLflow has different integrations. MLflow, scikit-learn, MLflow, TensorFlow, MLflow, PyTorch, all the actually integration it is having. Let me just show you. MLflow project, MLflow monastery, plugins, MLflow plugins. MLflow authentication, Python API. Now see, guys, here MLflow supports actually different kinds of API support. You can see artifact, autogen, cat boost, client, config. Now here you will see sklearn is also there. So somewhere I think, see, LangChain also it is supported, llama index, and I'm looking for the sklearn. See, sklearn is also there, guys. You can see sklearn. So it supports also sklearn. That means if you want to do the machine learning project with the help of MLflow, you have to use the sklearn API that time. Okay, MLflow.sklearn. Okay, and if you're doing any deep learning project, that time you have to choose TensorFlow either PyTorch. So in this project, actually the project will be implementing the deep learning project will be using TensorFlow. That means we'll be using this API that time. Okay, TensorFlow API. Got it? So here I'm showing you the demo, and I'll be doing one small machine learning project. That's why I will be using sklearn. Machine learning sklearn. Okay, sklearn will be using sklearn API. Okay, that's it. Got it? And see, the experiment we'll be doing. The experiment I'm going to save in a remote server. That means in a cloud. So here we'll be using something called DAGSUP platform. And to use the DAGSUP platform, guys, you also need to install the DAGSUP. So in the requirements, also mention the DAGSUP. Okay, and then try to install the requirements. Again, you have to execute pip install -r requirement.txt. It will install the DAGSUP. For me, I already installed the DAGSUP. Okay. Then login. So these are the library I need, okay, to implement this small example. Okay, now the next thing, I'll be creating the logging string. So this is the logging string, guys, I have created. That means if you want to log any information, you can use this login string. Now what I have to do, guys, I'll be creating one function here. Okay, so this function will give you all the evaluation metrics. You can see RMSC, MAE, R2 score. That means it will take your actual data and your predicted data. Based on that, it will calculate the RMSC, MAE, and R2. That's why I've created a function separately. Okay. Now let me show you what you have to do. Very simple example, guys. If you already did the machine learning, I think you know, okay, what I'm doing. Now see, here I'm loading the data. So this is the data URL and this is the CSV data, and with the help of pandas, you can read the data. Okay. And it's a, you can see it's a, I think semicolon separator. So if I open the data, it's a semicolon separator, you can see. Okay, semicolon separator. That's why you are giving separator is equal to semicolon. Okay. And if something is happening with the data, let's say if some issue is there with the data URL, that time it will give you the exception, and that exception you are doing the login operation. Then you are performing 10-test split, because I think you know, if I want to, let's say, train any kinds of model, first of all I have to do the 10-test split. That means I will be converting, I will be splitting my data in the training set as well as the testing set. So here I am doing. Then I'm taking my train X, test X, train Y, and test Y. So these are the things are common, guys. Yes or no? Tell me. So this thing you have already did, yes or no? I'm expecting you already know these kinds of, like, let's say, model training in machine learning at least. Yes. Then what I told you, guys, inside ElasticNet, we are having two parameters. One is the, we are having different, so many parameters, but I will be considering these two parameters, alpha value and L1 ratio. So let's take alpha value and L1 ratio. So here I'm going to take alpha value and L1 ratio. And see, by default, I'm setting actually 0.5, okay. And why I'm taking this system.argv? Because you can also give the value during execution of your code. Let's say whenever you will be executing this file, executing this demo.py file, that time you can pass the value as well. Okay. So this is called system argument. That means you can also pass the input during execution of your code. That's why I'm using this syntax. Okay. And if you're not giving any, let's say alpha value and L1 ratio, by default, it will take 0.5. Got it? Yes. Now see, the only change you have to do here. See, the only change you have to do here, let me show you. Let me copy the entire code. So I already prepared this code, guys. I just simplified and prepared for you. See, same code, only the change you have to do if you are using MLflow. See, you just need to write this line with MLflow.startRun. With MLflow.startRun. Inside that, you will be initializing your model. You will be training your model. You will be predicting. You will be calculating the evaluation metrics. And this metrics you have to log in the MLflow. That's it. You have to log in the MLflow. See, if you are logging any kinds of parameter, okay, if you're logging any kinds of parameter, you have to use log_param. If you're logging any kinds of matrices, that time you have to use log_matrix. Now I think you know what are the parameter we are using. Parameter wise we are using alpha and L1 ratio, and metric wise we are using RMSC, R2, and ME. Okay, that's why whenever I'm logging the parameter, I'm using MLflow.log_param, and whenever I'm logging the matrices, I'm using MLflow.log_metric. Tell me, guys, is it clear? So far, is it clear? Yes or no? Only the change is you have to write inside this particular statement with MLflow.startRun. So what MLflow will do? MLflow will start run this code, which will automatically start tracking your experiment, whatever experiment actually will be doing. So you don't need to do anything. Everything would be automated task, guys. Okay. So this is the syntax only you need to write, and this syntax. Okay. After that, I want to save this experiment in a platform. That means I want to save this experiment inside a, let's say, storage or inside a platform, inside a cloud. So here I'll be using one remote server to store this experiment. Okay, so here we'll be using something called DSub. Okay, DSub. Now let's open up the DSub website. Okay, let's open up the DSub website. So you can search for DSub, see in internet. So DSub, I'll try to open the first website. Now let me log out first of all. See, this is the DSub interface, guys. Okay, so this is another MLOps platform. So here you can do the experiment tracking. You can do so many things with the help of DSub. Dataset management, experiment tracking, model registry, data and model license. Lineage. Okay, you can perform different kinds of operation here. Okay, and it also supports different kinds of framework, different kinds of tools and technology. See, and it is also production grade tool. Got it? So here we'll be using DSub for the experiment. Experiment tracking. That means I want to track my experiment. Okay, I want to track my experiment here. Now the first thing, you have to create an account in the DSub. If you don't have the account, guys, first of all, create one account. First of all, you will see the sign up option. Try to create one account. Okay, with your email address, you can create one account. For me, I already have the account. I'll just try to log in operation. Okay, now let's select my account. So this is my account. Okay, now whenever you will create the account for the first time, it will give you different windows. So there you have to select experiment tracking, guys. Just try to remember, you have to select the experiment tracking, not any other service. Okay, try to select the experiment tracking and try to log in with your account. And this is your dashboard. This is your DSub dashboard. Okay, now here, first of all, you have to, what you have to do, you have to create a GitHub repository, and that repository you have to connect. Here. Okay, so for me, I think you remember we created our project repository, but as of now, I don't want to connect this repository, because going forward, whenever I'll be integrating this MLflow with my project, that time I'll be connecting this repository. As of now, what I will do, I'll try to create a dummy repository. Let me show you. So maybe I can close this at the tab. This is not required. Now I'll open up my GitHub. So let's open up my repository. Now let's create one, like a demo repository here. Okay, I'll create a new repository. I'll name it as MLflow test. Okay, let's say this is my repo name. Now let's keep it as public. Add the readme file. You can also get git ignore license, but as of now, I'm not going to add anything. I'll just create the repository. That's it. Okay, so now let's get back to my DSub. Now just click on the create button. So there is a create button. Now new repository, just click on the new repository. Now here you will see different options. Create a blank repository, create from a template, connect a repository. So I have to do the connect operation with my GitHub. Now let's connect. So you have to select the GitHub. If you're using Bitbucket and another service, you can select other as well. Now here, see, I have already previously connected different repository. Now I'll be connecting another repository. So I'll just click on add revoke access repository. Now select your organization. So this is my personal account. Now give the password, your GitHub password. Okay, sorry. Okay, so after that, you can select your repository, like which repository you want to give the access. So click on the select repository and search the name. So here what I can do, I can copy the name and here I can search it. Now see, this is the repository. I'll try to select and click on the save button. That's it. Okay, so after that, just try to select the repo. So this is the repo and connect the repository. That's it. Now see, it is connected. After connecting, you will get this kinds of dashboard. Okay, now click on the remote. There is a remote button. Click here and try to copy this URI, guys. Try to copy this URI, the first URI. Try to copy and open up your code. And here you have to mention, this is my remote server URI. So in this URI, my experiment would be saved, guys. Okay, so here just try to paste it. That's it. Now here I have written the logic. You can see with the help of URL parts. I think remember we imported one library URL parts. It will hit this URL. Okay, then it will do the model registration operation there. Okay, that means it will save my experiment, okay, in that particular URI, in that particular server. That is the thing. That's it. So these are actually MLflow related syntax. Okay, apart from that, you can see this is your like I mean the traditional code you usually write, okay, in your machine learning, like to train the model, to do the test split operation. Okay, so these are the code only. That's it. Okay, now see here what you have to do, guys. Here you have to write another additional line. So this is the line, guys. So to initialize with the DAX app, that means if you want to connect with the DAX app, you have to do the initialization. Okay, initialization, DAX app initialization. For this, you can copy this line of code. Copy this line of code and open up your code. And at the first, just try to mention it. Here I can mention. Okay, so import DAX app. DAXapp.init repo owner. So this is my repo owner. This is my username. You can see if I show you, this is my username I've given, and this is the repo name, MLflow test and MLflow. That means you want to track the experiment of the MLflow. That's why you have given the true. That's it. So this is the simple configuration, guys, you have to perform. That's it. Nothing else. Nothing else. Previously, the configuration was a little bit different. Now the configuration is completely changed. Okay, that's it. Okay, now let's open this MLflow UI. Now you can see there is a button, go to MLflow UI. Now if I click here, you will see that it will open up my MLflow server. And initially, okay, so I can see some experiment. Previously, I think I did. Which one this is? MLflow test. Okay, so I think I selected that previous repository. Okay, fine, no need to worry. That is fine. This is fine, but for you it will be empty, guys. There will be nothing. Let me delete, so I can also delete my previous experiment. Okay, see, that's how actually you will see this kinds of window. Okay, fine. Now let's start the execution. Now I'll do the experiment tracking. Okay, so what I will do, I'll open up my terminal, and now let's execute this demo.py. So I'll just write Python demo.py. Now see, it will load the data, it will train, and it will save all the artifact. See, it is executing. And this is the parameter, and this is the metric I got. And now it has saved my model. You can see it has saved my model inside my MLflow. Now if I go to the MLflow, if I do the refresh operation, see guys, this is the experiment it has saved. Okay, 19 seconds ago, this is the experiment. Now you can click on the experiment. You can see the experiment ID, created date, okay, duration. Even you can also see the parameter value as well as the matrices. Okay, everything is visible. Even you can also see the model matrices as a graph. System matrices, there is nothing. Artifact, you can see the model as well. See model.pickle. So model has also registered here. Now we can click on the model section to see the model as well. See, so this is the model, guys. Okay, so model I don't need as of now. I only want to see the experiment. That's it. So this is my first experiment, let's say. Okay, now if I do the second experiment, so what I will do, I'll open up my terminal. Now let's say I want to pass any other parameter. So what I will do, I'll give this command python demo.py. Now let's say I will give my alpha value is equal to 0.3 and L1 ratio I'll give, let's say 0.6. Okay, now previously what I've given, guys, I've given 0.5, 0.5. I think remember 0.5, 0.5. Okay, alpha 0.5, L1 0.5. Now here what I've given, alpha 0.3 and L1 0.6. Now if I execute the program, now see, it will use this parameter to train the model again, and it will log the information in my MLflow. See, manually I don't need to do anything. Everything would be done automatically. Okay, done. Now if I get back, refresh here, see another experiment, it has tracked. Okay, now you can also open it up and you can see this is the parameter you have given and this is the MSC score you got. That means this is the matrix you got. That's how you can also perform another execution. Let's say here I will give 0.7 right now. Now let's execute again. That's how you can perform 100 different execution, 100 different experiment. Okay, and it will save all the logs. It will save all the, let's say, parameter, all the matrices and everything. So 3 execution I did. Now see 3 artifact I got. See, 3 artifact I got. Okay. Now you can ask me from this 3, experiment, which one is the best model? How to select which one is the best model? Okay, to select it, just try to select every model. That means all the experiment, just try to select, and there is a compare button. Just click on the compare. Now it will give you this kinds of plot. Actually, this is called parallel coordinates plot. Okay, this is called parallel coordinates plot. Now, parameter wise, I have alpha value and L1 ratio, and metrics I'm having 3 metrics. Okay, as of now, 1 matrix has selected, which is R2 score, but I also want to select RMSC and MAE. Okay, all the metrics I want to select. Now see, this is your graph looks like. Now you can ask me how I can select the best model out of it. Now tell me, if I'm training any regression model and if I'm considering RMSC and MAE, so this metric should be less or high. This metric should be less or high, guys. Tell me. RMSC should be less or high if I'm considering a good model. RMSC or MAE? Tell me, guys. Quickly tell me in the chat. Tell me, anyone? RMSC, MAE should be less or high if I'm considering any good model. Less, because this is a loss, right? This is a loss. Loss should be always less. Okay? And what about R2 score? R2 score should be high or low. Tell me. R2 score should be high or low. What about R2? R2 should be greater. Yes. Now just try to see. Based on your theory, just try to see. Try to select the very low MAE score. Now see, this is the very low MAE score. This line. Very low MAE score. This is very low RMSC score. You can see. And this is very high R2 score. That means just try to see this line. Where it is coming. It is coming L1 ratio 0.6 and alpha 0.3. That means if you are taking 0.3 alpha value and 0.6 L1 ratio, you are getting the good model here. From this, 3 different model, this model is good. You can see R2 is high, RMSC less, MAE is also less. Now try to figure out this model actually. 0.3 and 0.6. So here you can see run ID, L1 ratio 0.3 and 0.6. 0.3, 0.6. Yeah, you can see the second one. Now you can open the second experiment. This one. This is the ID. Just try to open it up. Now see, this is my best model. And what is the accuracy score, guys? I'm getting here. I'm getting 0.16. Okay, 0.16. This is the R2 score I'm getting. And this is the minimum loss actually I'm getting. That's how you can select your best model out of 100 different model, 1000 different model, lakhs different model. Tell me, guys, now is it clear why we are using MLflow and how we are selecting our best model out of it without using any kinds of hyperparameter tuning? Tell me, guys. Clear, all of you? If it is clear, so please give me a thumbs up in the chat. If it is clear, guys, please give me a thumbs up quickly. Okay. Great. So this is why actually we use this MLflow for the experiment tracking. And from this experiment, we select our best model, okay, out of different kinds of model. Okay, this is the idea. Now you can do as much as experiment you can. You can also take different parameter. It's up to you. And that's how actually you have to select the model with the help of this parallel coordinate plot. Okay. So this plot. That's it. Now let's get back. And if you want to delete this experiment, what you want to do, guys, you can select any kinds of experiment and you can click on the delete button. It will automatically delete. Okay. That's it. Now you can also select the color. Let's say I want to get this white theme. You can also take it. Okay. Even they have also given the documentation, everything. This is one amazing tool actually they have implemented. Okay. Fine. Okay, so we'll be following this concept only. Okay, this concept we'll be doing the experiment tracking and we'll be selecting our best model out of it. Okay, this is the idea. Okay, so if MLflow is clear, now let's discuss about DVC. The next MLOps tool, DVC. Full form is data version control. Data version control. Okay, but we'll be using DVC for the pipeline. Okay, pipeline tracking. Because here we'll be creating pipeline. Okay, training pipeline. That means data ingestion, prepare based model, model training, model evaluation. So step by step, all the pipeline will run. And to track this pipeline, I need DVC, data version controlling. Because again, deep learning is a costly task. Deep learning is a time-taking task. Okay, that's why whenever I'm performing the retraining operation, I don't need to execute all the pipeline. Okay, if it is not required. So that's why we have to do the pipeline tracking. Okay. Now let's discuss about DVC, guys. Now you can also search for the DVC on Google. So DVC, data version controlling. So this is another amazing MLOps tool. You can see data version controlling. Even they have also integrated GenAI. Okay, nowadays. So you can see with the help of DVC, you can perform different kinds of thing. Okay. And to use this DVC, actually you have to use the Git. Okay, Git client you have to use. Then you will be using DVC. Okay. So now let's try to see the DVC example. I'm going to open up my code. Fine. Okay, so here I'm going to create a folder. Let's say, first of all, I'm going to create a folder. Which folder I can create, guys? Let's say I can create, let's say pipeline. Okay, pipeline is my folder. Inside that, I'll be creating some of the pipeline. Let's say stage 01. This is my first pipeline. .py. Then I'll be creating another pipeline. Let's say stage 02. .py. And let's create another stage. Okay, let's stage 03. .py. You can create as much as pipeline you can, but as of now I've created 3 pipeline only. Okay, that's it. Just a minute. Okay, now what I told you guys, if I want to use the this one DVC. Okay, DVC. So first of all, I have to install the DVC, and to install the DVC, what you have to do, you have to use one package called DVC. So inside requirement, just try to mention this DVC. And DVC wise, we also we already installed DVC. Okay, I think you remember in our setup we already installed a DVC. So if you haven't installed, again you can execute this pip install command. So it will install the DVC. See, requirement is already satisfied. Okay. Now the second thing what you have to do, you have to initialize the Git. And to initialize the Git, just write Git init. Okay, Git init. That's it. Now let me initialize the Git. So I think Git has been initialized here. See, okay. But now we can start the DVC because this is the requirement. So if you are not initializing the Git, then your DVC won't be working. Okay. Now let's see here. I'll create a file. Here I'm going to create a file. I'm going to name it as DVC dvc.yaml. Okay, so this is the file you usually create to write the DVC related command. Okay, so inside that we'll be mentioning all the command. That's it. Now let me first of all write some logic inside this stage 1, stage 2. Okay, so here what I can do, I can write some logic. Let's say here I can create a folder. I can name it as artifact. Okay, artifacts. Inside that I can create one file. Let's say I can create what I can create, guys. I can create anything. Let's say I'll create one txt file here. So let's say text.txt. Let's say this is my data file. Okay, inside that I'm having some data. Let's say hello, my name is Bappy. Okay, anything you can write, it's fine. Now in the stage 1, I'll just load this file. So to load this file, guys, what I can do, I think remember we can use with open. And inside that I can mention the file name. So it is available inside artifact slash text dot text, I think text dot txt. Okay, I'll be loading as a read mode. F, then after that I'll simply just write f dot read, and this is going to be given the content, so I'll store in as variable, and simply I can print this. That's it. Now if I execute this stage 01 py, so Python, it is available inside pipeline stage 01. Now see, it is printing me hello, my name is Bappy. Okay, I think it is clear. Fine. Now let's write the stage 2 as well. Okay, so here I'm going to write stage 2 as well. Since it's stage 2, what I can do, I can write the same code. But after reading the content, it will do one thing. It will create another file actually. It will give you one output actually. So here what I can write, let's say or see here, simply I can write like that. I can import operating system, and with the help of operating system I can create one file here. So waste dot make directories. No, I don't want to make directory. I want to create a file. So simply what I can do, I can with open it. Write mode, and here I'm going to do the write operation. Inside that I'm going to write something. Let's say welcome guys. Okay, anything you can write. This thing I don't need. That's it. Okay, now see, if I execute this stage 2 right now, you'll see that it will create a file after reading it. So let's execute stage 02. Now, okay, so it has created where, guys? Okay, it has changed my okay, sorry. So I have to create another file now because I'm replacing the same file. So again I can write hello, my name is Bappy. Now stage 2, I can create another file. Let's say output.txt. Inside that I can create it. Okay, now I think it will work. Now execute again. Now see, inside artifact it has created the output.txt and welcome guys is written. Okay, now inside stage 3 also you can write some code. Let's say what I can do, I can copy this code, and inside that I can mention it. So it will read the output.txt only. Okay, output.txt. That's it. So let's say this is, as of now, just try to consider this is your pipeline. Okay, this is your pipeline. Going forward, we'll be using our actual pipeline. That means we'll be using our, let's say, model data ingestion, prepare based model, model training, model evaluation. This is going to be my pipeline. Okay, as of now, I've just created some dummy pipeline just to show you how it will perform the pipeline tracking. Okay, this DVC, that is the idea. Now you have to write the dvc command. Okay, so open the dvc.yaml right now, and inside that you have to write all the dvc related command. Okay, fine. So the first thing, you have to give the stages. Okay, stages. Inside stages you have to give the stage name first of all. Let's say here I can give stage 01, stage 0. Let's say this is my stage 0, because you can see I want to execute stage 01, this one. Okay, so inside that I want to, sorry, just a minute, let me check, stage underscore 1. So inside that, first of all, I have to give the command cmd. So what should be the command? Command should be python okay, python. I need to execute my pipeline. Pipeline is present inside pipeline folder. So pipeline slash stage 01.py. So this file would be executed at the very first stage. Okay, and if I want to execute this file, so what would be the dependency, guys? So the dependency would be this file itself. So here I can mention, just a minute. So this file should be the dependency itself. Because if this file is not available, then will my execution will be work? No. So that's why this file should be present first of all inside the directory. Otherwise this execution won't be happening. That's why you are giving dependency is equal to this file itself. This is going to be a dependency. Okay, that's it. Okay, now tell me, this file generate any output? Stage 01.py, is it generate any output, guys? Tell me. Will it generate any output? Will it generate any artifact? No. That's why it won't be giving any kinds of output. So output I don't need to mention. Okay, output I don't need to mention. That's it. Now the second thing, what you have to give, you have to give another stage. Now let's copy the same thing, and here I can mention. Here you have to give this stage 2. Inside stage 2 would be executed, and dependency should be stage 2, guys. Okay, stage 2, because this file should be exist. Okay, otherwise it won't be working. And another dependency, no, another dependency is not there. But if you see the stage 2 will generate one file called output.txt. So let's write here. So here I can write just a minute. So here I can write outs. Okay, output should be artifacts slash this one, output.txt. output.txt, because it is going to create this file. Okay, this should be the output. That's it. Now I'll copy and I'll create another stage. This is going to be stage 3, and I'm going to execute the stage 3. And if you see the stage 3, it will read. Okay, what it will read? It will read the output.txt. So definitely as a dependency, I have to also give this one. So output 3, I also give this one. Okay, as a dependency. So this file should be present, output.txt. Okay, because this is reading, you can see this is reading output.txt. That's why it should be a dependency. Okay, and it is not generating any output. I can delete it. That's it. So this is the simple command of DVC. Okay, so with this command, actually it will track all of my pipeline. Okay, now how it will track, I'll tell you. Now see, to initialize the DVC, what you need to do, you have to execute some of the commands. So let me show you all the command you have to execute. So I think I can mention here. I can create a file, readme.md. So DVC command. Okay, so first of all, you have to write this command dvc.init. So dvc init. So let me initialize the DVC first of all. So here I will initialize. Now guys, you can see DVC has been initialized. So if it is initialized, it will create a folder. You can see .dvc. Okay. Now the next thing, you have to run this command dvc repro. Now see, it will do the pipeline tracking automatically. See, dvc repro. If I execute, okay, if I execute it, so first of all, let me delete this output, because output I have manually created now, so I don't need it. Now see what will happen. It will execute all of my pipeline. Okay, so it is telling source to zero dependency Python does not exist. Let me check. Is stage underscore 01.py pipeline. Okay guys, let me check. Stage underscore is TAAGE 01.py. PIPP line. Why it is giving me the error? MLOps tool demo. Fine. Okay, I have to save it. So let me save. Now let's try DVC repro. Okay, so it is giving this error. Does not exist, because it is exist now inside pipeline, you can see. Python slash. Let me check guys. Dependency Python does not exist. It is fine, I think, but why it is giving me the error? It's coming from the dependency, I think. Dependency Python pipeline stays. Okay, if I comment this dependency, let's see what happens. Failed to reproduce test 2. In error, the system cannot find the specified path. Test 2. Okay, as of now, let me comment this dependency. I don't need. Now I can re-execute it. Okay, so now see, it has executed successfully. I think some issue with the dependency. Maybe they have changed their version. Previously, I think we can set this dependency. Okay, so dependency used to work. Now I don't know why they're giving the issue. I'll check it out in the documentation. Now see what will happen. Now you can see execution is done. Now it has also created my output. Okay, .txt. That means it has created. Now see, if I again execute this DVC repro command, see what will happen. See, it has skipped. You can see running stage 1. So didn't change, skipping. Stage 3 didn't change, skipping. That means I haven't changed my code. Okay, I haven't changed my code. I haven't changed anything. Let's say I haven't changed any kinds of feature. So if I'm not changing any kinds of feature, if I'm let's say doing the retraining operation, so is it really suitable? Tell me. Let's say if my data is not changing, if I'm not changing any kinds of feature, then why I'll be executing my pipeline again? So if I'm executing my pipeline again, so what will happen? That means it will do the computation. That means again it will increase my cost, right? Okay, now let's say if I'm changing my data, let's say text.txt, I'm changing my data. Let's say I'm adding some more data. Let's say I'm adding another line. Let's say my name is, let's say, Alex. Now see, this pipeline will execute. Now if I again perform the DVC repro, now see, it has executed. The first one is executed. See, the first one is executed. Second one, it's not executed because output is already exist. Okay, now let's say output is not there. That means third step should be executed. Let me show you. See, now third step has executed. Sorry, second step will create. Now see, output has generated. Now if I again execute, nothing would be generated. It is skipping my pipeline. Okay, this is called actually pipeline tracking. That means we're tracking the pipeline here. Okay, if anything is not changing inside my pipeline, I don't need to execute my pipeline. That means I don't need to execute my code. If I'm executing my code, that means I'm doing the unnecessary computation because it's a deep learning project. Okay, I hope you cleared. Now there is another command. If you want to see the graph, like how it will create the connection, so you can execute this command, DVC DAG. Now see, interconnection, you can see stage 1 it is not connected because stage 1 it is only reading it. Okay, now stage 2 it is reading, and stage 3 is connected with stage 1 because you can see stage 2 is generating one file called output.txt and stage 3 is reading it. Okay, stage 3 is reading, that's why there is a connection. Okay, so this is called actually pipeline tracking, guys. I hope it is clear now. Okay, and that's how with the help of DVC we can perform the pipeline tracking. Sir, I am from BBA background. Now I don't need to suggestion. I'm completed the Python intermediate level, Python resistance statistics, ML. So now what should I do? Now just try to build some end-to-end projects. Okay, fighter journey. So in my YouTube channel, I think you remember we created end-to-end one playlist called production ready machine learning project. Just try to attend this class. Okay, try to attend, create this kinds of project, and once you are comfortable creating this kinds of project, you start with deep learning topic. Okay guys, so this is all about our MLOps tool like MLflow and DVC. Okay, and this concept will be using going forward actually whenever we'll be implementing this project actually. Okay, now tell me guys, is it clear so far? Everything is fine? I don't understand how I can start my own project. If possible, give me detailed guidelines so that I can start the DS field. Attend this project guys, this firefighter journey. So attend this project first of all. At least 1 to 2 session, you will automatically get the idea how we can start your own project. Okay, everything I have already discussed. If you open it up now, let me show you. So here I've already discussed. So resume discussion and career guidance. So in this session, actually, I already discussed how we can start the project, even first session also. Okay. So far guys, everything is clear. Whatever things I taught you, let me know. This MLflow demo as well as the DVC demo, let me know. If yes, so please give me a quick yes, quick like in the chat. And I will share all this source code with you. Okay, no need to worry, everything would be shared in my GitHub only. I will share everything. Okay, after the session I'll try to commit. From there you can get the code. Okay, so it's already 10. So now I think we can end the session if everything is fine guys from your end. So please write something in the chat. And this is the playlist guys. So here all the video would be uploaded. Okay, great. So thanks for joining the session guys. I hope you are enjoying the session. So in the next video, we'll be starting with our this one. Component notebook experiment. Okay, first of all we'll be doing the notebook experiment, then we'll be creating the component implementation. Okay, or modular coding implementation. Yeah, hi, thank you. So thank you guys for joining the session. Bye everyone, good night. Thank you, bye.